Question number 17. A box of weight 40 Newton is pushed with a horizontal force of 20 Newton along level ground. So you have a box of weight 40 Newton is pushed with a horizontal force of 20 Newton. Pushed with a horizontal force of 20 Newton for a distance of 2.4 meter. For a distance of 2.4 meter. Okay, 2.4 meter. Then the box is then lifted at constant velocity through a height of 1.6 meters by a vertical force. By a vertical force, it was lifted by 1.6 meters, and that too what, with constant velocity. Okay, then what is the total force done on the box by these two forces? Total work done. Now work done in this one, let me call this as W1. Work done in moving the object from here to here should be 20 into 2.4, which should be equal to how much? 48 Newton. 48 Newton meter, 48 joules over here. Now the work done in lifting this object from here to here. Now see, there should be some force being given here, right? What is the force here? See, if you are lifting it with an equal velocity, with a vertical force with a constant velocity, so what is the initial force acting on it? The initial force acting on the object is nothing but 40 Newton. How do I know? It's already given. A box of weight 40 Newton. What do you mean by this? It's nothing but weight, mg. It's already given here. And you are going to lift it also with a force of 40 Newton. Where is it given? It's not given here. Okay, if you lift it with it, then probably it will move. No net force is acting. It will move at a constant velocity. So therefore, the upward force is 40 Newton, and the distance moved is 1.6 meter. So the weight, the work done lifting it upwards should be 40 multiplied by 1.6, which should be equal to how much? So 16 fours are, which should be 64 joules over here. So what's the total work done? Total work done should be equal to 48 plus 64, which should be 8 plus 4 is 12, 1, 7 plus 4 is 11, 112 joules. The answer should be 112 joules. The nearest answer is seen to be 110 joules. Okay.